Let's do a little orbital physics, orbital dynamics. Okay. Let's say I have the sun and the earth. Does the sun rotate around the earth? Or does the earth rotate around the sun? Typically we think, okay, earth rotates around the sun. That's correct. Sun also rotates around the earth. That's also correct. Two bodies rotating around each other. Let's make it simple. Let's take two basketballs and tie them with a string. Rotate them around each other. Where's the common center? Where's the point of rotation? Well, it's in the middle, because mass is equal on both sides. So they're going to orbit each other. What if we make basketball and a softball? Well, the basketball is more massive, so the shared rotational point is going to shift toward the basketball. So the rotation looks like this: softball, basketball. Now, if the mass of the one object is overwhelmingly larger than the other object, such as the sun and the earth, okay, 2,000 units, 1 unit. It's actually even bigger than that, but you get my point. It's possible for the shared rotational orbit to be inside the one object. So the sun actually wobbles in an orbit around the earth because they share a rotational vector to each other. But that orbit is so tiny, it's so skewed toward the sun that it's actually inside the sun. So the sun just wobbles. If you made the earth bigger, it would move outward, just like in the scenario of two equal-sized objects. Same thing applies to the car. Think of this as the big car and this as the metro. It's going to create a rotational vector, and the car will go toward the left.